I am joined here on the show floor at PPMA 2017 by Ian from Alrad Imaging. Ian, thanks for joining us. Give us a rundown as to what Alrad does, please.
Produce or detect light, basically. So cameras, lasers for machine vision, lighting, but basically machine vision and process control via vision.
And obviously machine vision, a huge part of the industry right now, and indeed a huge part of the PPMA group of associations.
Yeah, and expanding use with people wanting 100% inspection and to make sure things are actually packaged correctly, the right code is put on it. So we've even got some coding products as well for coding some bits or serializing things.
Well, let's take a bit of a look at what it is that you've brought with you here today to the show, some of which is inside this glass cabinet here. To talk us through some of your range, please, Ian.
So on the top left, we've got a line scan camera that's used over a web or over a conveyor belt. So when you've got a moving object, you can get a high resolution image of it moving to do inspection of anything from print to bottling, where you'd want to look at the label on the bottle, how full a bottle is, whether it's got a cap on it and everything at full line speed. We can also got a full range of small area cameras, from board cameras that can be incorporated just to detect the presence of something in a machine, as well as inspection. We got customers that use that for full print inspection on labels that are done as well.
Being a little bit of a camera geek, this one over here caught my eye. Tell me what's so special about this.
That's the new one with the 4-channel Coax Express interface. So you can use standard coaxial cable to run digital data. That one's 12 megapixels, 180 frames a second, if I remember rightly.
Good memory, because I've got the label just here, so I can test you. That is accurate, and that's a really long range for such a high frame rate and resolution.
Yes, and you can run it down 50-meter cables, so you can run it well and truly out of the machine to the process computer. As well, whereas at USB and everything, you're limited to 4 or 5 meters, so you have to have a small computer within the machine often to then run the data out from there.
Good stuff, good stuff. And then towards the bottom here, what have we got? You've got a laser marker there.
Yeah, so starting at the bottom, we just got a ring light, but it's a sample of machine vision lighting, because that's an important part of machine vision, is to actually get the lighting right. If you get the lighting right, the inspection task gets a lot easier. And then we got lasers for structured light, so if you're doing 3D imaging or 2D imaging to get a shape, the shape changes of the structured light as the object moves under it. And then we've got the laser for marking. That's a small laser marker for things like serializing or a small part number or something. It'll only do about 25 mil, but it's a low-cost solution for laser marking. It's not a big laser cutter or anything, but it's a very low-cost solution for if you just want to put a serial number that's permanent rather than just printed.
I'm easily pleased at shows like this where we've got cool cameras, we've got robots, robotic arms, and we've got lasers. That's pretty much the Holy Trinity for me.
Cameras on robots.
Cameras on oh yes, of course, vision systems built into some of the robot arms we've seen as well. What have we got? What have we got going on here?
So some examples of some of the processing. We've got a smart camera that will do all the processing inside. It's got I/O on it. That's just a breakout box for testing position.
But the intelligence is built into the camera unit. That's the cool thing there.
It's a run by itself. So you just put the power on. Once it's been programmed and you set it in there, it can start. So the morning you switch it on, it starts inspecting, it starts reading, and it'll give out the problems. This one is a microscope replacement. It's just a HDMI camera to a monitor. So if you're, instead of a standard microscope staring down it all day, you can look at a bigger screen, inspect it, much less eye strain, and you can also get much high resolution images. We could replace the HDMI with a Gigi or a USB camera into a computer. You could then save the images as well for later inspection. Here we've got a higher resolution camera. This is a 4K TV type standard. So it's that small one is 4K TV standard. Very small cameras now for high resolution. Yep. Back to the marking, we also supply the Lynx continuous inkjet printer for small batch numbering. Again, it'll do 2 lines, and that's for, again, small manufacturers want small bits. It'll only do a couple of lines, but we can then also OCR it to check that it's been printed correctly, which is why we've teamed up with Lynx, because we can provide the inspection as well as the printing, so people that want just small serial number and small batching, and it can automatic date coding things as well.
Sure.
It's also software built in for the date coding.
Well, thank you very much indeed, Ian. As we know, imaging sensor technology is great, but you need some decent glass in front of it to make some sense out of it. And speaking of decent glass and making great sense, I urge you to come over here as we chat with Graham from Ricoh. So, Ricoh, that's a brand I feel as though I know and I trust. And
massive in the printing industry.
Massive in the printing industry. I mean, I'm thinking from the photography field as well, where I kind of half recognise these as miniature versions of lens that I might stick on the front of one of my cameras.
Absolutely, but in fact they're machine vision, going from very high resolution down to our general standard resolution range.
So, I just want to stop you there because I can see on the banner behind you here, you're talking 9 megapixel lenses. Yes. So just clarify for me in my relatively uneducated head, if you will, I think of resolution as something to do with the sensor, not necessarily to do with the lenses or the glass. So put me right here because I'm sure I'm wrong.
Yeah, I mean, in a modern age, it's very easy to say with a sensor how many megapixel it is, because it's the number of pixels on that sensor. So it might be that they have 10 million. And so we then say 10 megapixel. Now, because of that, you need to, and obviously the size of those pixels is really important, because the bigger the picture, the more light it can gather. So now what you need to do is, when you design your optics, you need to rate them so that they can produce the right resolution all across the sensor, which is what our optic does. It's not just 9 megapixel in the center, it's 9 megapixel on the periphery, right in the corners.
So you're not getting any aberrations, any distortion in the fringes?
No distortion, tonal response is excellent. So that's how we design ours, and we're very careful about how we relate to our lenses. So if we say they're 9, they're 9. Okay. But in fact, they punch above their weight as well.
I'm sure they do. So just talk to me quickly about the range of lenses you've got here. And again, let's just start off with the miniaturization, because I'm used to camera mounts, whether it is E or PL or EF. What's the mount that you got here?
All based around C-mount, which is the original television mount, which is a 25.4 mil, was 1 inch. So, but in fact, the optics, even though if we say it's a 1 inch lens, it's not, because it can't be bigger than the mount. So here we've got our 9 meg range, that's our absolute elite. And then we're moving down, we've got some 5 megapixel, they're on a 2/3 inch format. And then we've got our super close focusing 2 megapixel range, very popular, worked down to about 10 centimeters. And moving down, we've got our older 2 megapixel range. You can't stop those because a lot of people have designed their equipment around it. Of course, yes. So we were going to withdraw them, and then people said, don't do that, it's madness. And then our original ones, some of these designs are dating back, 25 years. For VGA, that's only 0.3 megapixel resolution. But again, extremely important. It was equipment based around that. And then we got some zoom lenses, very specialist ones as well. There's a UV lens there, and that works at a very specific wavelength. So UV light is used, it's quartz optics. So actually glass stops UV. So the optics have to be redesigned so that quartz allows it to transmit. And then that's looking at forgeries and things like that. Really important. Line scan lenses, again, they're very specific. They come with a special mount, like a Nikon mount or a Pentax K mount. And that's used with a special sensor with one line. But means you can scan it so quickly, it'd be looking at P's on a production line, and as the P goes across it, it takes up a certain amount of pixels. If the P's too big, it gets blown away, and that goes to make something else, mushy peas maybe. If it's too small, again. Same with peanuts. Blow them away, you get your peanut butter. But that's old school. But that's exactly what line scan does. But it does it really quickly.
Fascinating stuff. Listen, thank you very much indeed for chatting me through. I'm sure you could, and I'm sure I would love to chat with you about cameras all day, because I know you've been in this industry for
36 years.
36 years, since you were 4. Anyway, listen, Graham, thank you very much indeed. Listen, thank you very much, Ian, as well. I hope you've had a great PPMA show. Look forward to seeing you both again next year. Bye for now.